say 1, 2, 3, 3 levels in this query. And as I said, for these kind of subqueries, what we should do, we should start with the innermost query. So here the innermost query that we have is not correlated, right? So how? Just look at it. If I am saying select purchase price from supplier for the product number 0178, I don't need any information from the outer queries. This query is self-sufficient. So I will show you the table also, and from that table we will work it out. From this query for the product which is 0178, we will get all the purchase price which is being provided by different suppliers. Now once you have this data, that probably one column with the purchase price of all the suppliers, now what we need from this outer query here, we want to find out the supplier number from supplies where the product number is same and the purchase price is greater than any one of those prices, right? So that is something which makes it a lot interesting. And here in both these queries, if you look at, the table involved is same, supplies and suppliers. That's the same table which we have, and interestingly the purchase price information is available in supplies table only. Okay, yeah, so let me underline that. Supplies and supplies. What are we doing from inner supplies? We will get the list, right? So let me not write those things, you would see that. I'll take you to the table. So what do we want? Well, in this outer query where we want supplier number from supplies for the same product, where their purchase price is greater than at least one price which is offered by the suppliers here. Okay, so here in the outer this query you should expect supplier numbers. Great. Now let's come out to this query over here. What we need supplier name from supplier. Now this is different. Okay, so these two tables are same. Let me call these A, whereas this table B is different table. Okay, and why do we have the supplier table here? Because we want to find out the name of the supplier, right? So the whole query, what is it doing? We want the name of the supplier who are offering the price of this product 0178 greater than at least one price available. Okay, well, why would we do that? It could be interesting, right? So what I'll do, as I said, let me take you to the example, and from that example again we'll try to understand this thing. So that's the homework I did. All right, now pay attention to these two tables that we have, and I would say that you should first focus on this table. Why this table? Because we are referring to this table multiple times, right? So this is our table A, this is table B. In my query, let me take you back to this query. In these two queries, if you look at, right, the innermost query, let's focus on that. We want the purchase price from supplies for the product 0178. So let's go here. All right, so these are the purchase price that we have for only these this product number 0178, 0178. Good. And let's get the purchase price. Now here nothing has been mentioned which you should treat as null. Good. So your innermost query that you have here will select purchase price from supply A for this product 0178. Good. So that value you would see in the next slide, right? In the next slide we have some animation also. So now from these values, if you get, right, what we want, let's now go to the outer query. This value would be returned by the inner query. What do you want from, wait a second. What do we want from the outer query? Select supplier number from supplies where the product number is 0178 and the price that this guy is offering is greater than one of the prices that we have there. Any, it should be greater than at least one, Okay, and once you find that out, let's see. Okay, so here the prices that we have, well, I think we'll get that in the next slide also, but let me list it, or probably you can see this is big enough. Here, if I can read, this is big enough. Now from these supplies, I want the supplier number with the value higher than at least one of these, right? So what do you say about 37? For 37, if you're looking at as the supplier number, its purchase price is 16.99, which is the lowest, right? So this supplier number 37 does not qualify. Okay, what is the qualifying condition? That the price should be, the purchase price that you have should be greater than at least 1. How about 68? Now this supplier number 68, if you see, its price is 17.99, which is greater than 16.99 and 16.99, right? So let me put a star next to this guy, or the supplier number 68, because this value is greater than at least 1. What do you say about 69? Well, 16.99 is not greater than even 1. 94? Well, for 94 also, if you look at its price, 18 is greater than what? It is greater than 16.99 as well as 17.99. Okay, so what will happen from the next query that we have, this one, we will have these values. What are these values? The supplier number 68 and the supplier number 94. And then once you have those two values, once you have these two values over here, then the outer query gets a lot simpler, right? So the outer query is using the table's supplier, and from that supplier we need the name of only the supplier that figures in the list that we have obtained in the query number 2. Let me mark them as query number 1, query number 2, and query number 3. All right, so let's see. Again, here we have some data which will help us in summarizing everything. The inner query will return these purchase prices for the product 0178, null, and then 16.99. All right, and out of these, this value and this value are the ones that would result in this this whole statement to be true. This will be true only for these two values, 17.99 and 18. And those two suppliers, they correspond to supplier number 68 and 94, right? And when you use this supplier table with the corresponding supplier number, like this one, 68 is the wine, that's 68, yes, 68 is wine depot, and 94, well, we can't see 94 here, but don't worry about that, we can find that out. Okay, so the wine depot and the wine crate. So what's the message? Well, if you have an example with the query, example of the table and the query, then the things get a lot easier. Okay, so now let's move on to even more interesting clause, exists, right? So how this exists is interpreted, let's look at that. Now this function, right, we call it clause or function, whatever you call it, checks whether the result of a correlated nested query is empty or not. This is something you need to keep in mind, right? And as it sounds, we will make use of the keyword exist along with not exist. So let's understand exist first, and then we will try to understand what I'll say, inverse of this, which is not exist. Well, it will return true or false depending on the result of the inner correlated query. So this would be Boolean, true or false. Now let's try to understand when is it going to be true and when is it going to be false. Exist means there is at least one tuple that satisfies the condition, right? Not exist means there's no tuple that satisfies the condition. Okay, so Let me go over this thing and then we'll have some examples. So exists returns true if there is at least one tuple in the result of the nested query, otherwise it returns to false. Whereas we have the other related clause or a function, you may call it, which is called not exist. So if you follow how exist works, then not exist is even easier to follow. So the not exist function returns true if there is no tuple in the result of nested query, otherwise it will return false. Okay. So what we will do, let's look at an example. All right. So as I always say, or let's see, right? We'll think about decoding it later. If that is simpler enough, probably we don't need to think too much. We want to select supplier name from supplier table, and you know what? We are using where exists, select star from supplies, where r dot supplier number is equal to s dot supplier number and s dot product number is equal to 0178. Now question arises, is it a correlated query? Probably something that we can immediately answer. Is it a correlated query? Right? Yeah, the answer is yes. Let's look at it, right? So we have two tables, supplier that we are calling as R and suppliers which we are calling as S. Now pay attention to the inner query first, inner correlated query. Now inner correlated query is joined with the outer table R on the condition that R dot supplier number is equal to S dot supplier number and S dot product number is equal to 0178. So we are interested in the product number 0178 and we are interested in that supplier number, right? The name of the supplier number who has supplied the product 0178. That's what we are doing here, right? In this query, if you look at, this should be simpler, where we are filtering out only the product which is of our interest, and that is product number 0178. And what are we doing here? Doing a kind of join, right? And now question arises, what is this select doing, right? Here we are finding out in this inner query, if you pay attention to, we are finding out the number of tuples corresponding to this product number 0178 for which we have the supplier, right? And if let's think about a supplier, right, with supplier number 37. So how will this query work? Well, from the supplier table you will take one tuple at a time. Let's assume that the supplier number 37 we are taking. Now for that supplier number 37, what you will do for that tuple, you will check at the supplier number here 37 and you will see whether we have the corresponding entry in the supplies also. We will have the entry in the supplies table only if the supplier is supplying some product. When will we have the entry of a supplier in the supplies table? When a supplier is supplying the product, right? If there is no entry in the supplies table for a supplier, then that means supplier did not supply any product, right? So that's precisely what we are doing, joining these two tables, supplier table and supplies table. This is the join condition. One more condition that we have here is that we are interested in the product 0178, right? So even though supplier number 37 is there in supplies, if that guy is not supplying the product 0178, then there will not be any tuple in the result. Is that making sense? Right? So here, if there is no tuple in the result of the inner query, then exist will return in false. Right? So if 37 is a supplier who has supplied other products, not 0178, then the result of this inner select star will be an empty set. Right? If that is an empty set, then when you say where exists empty set, it will result into false. And therefore, the supplier with the name 37 will not be listed. Whereas, if the supplier had, if 37 had supplied 0178, then this will return in true and we will list that supplier. Good? So now, similar to exist, we have a not exist also, right? So if I replace exist by not exist, then what suppliers I'll list? Right here, the suppliers that you're looking at are those who supply the product 0178, right? If I ask you a very simple query, question to modify this query such that we list those supplier, the supplier name, who do not supply the product 0178, what will you do? Replace exist with not exist. It's that simple. All right? The complement, you may call it. Okay, so now this is a very interesting query, right, which highlights the usefulness of not exist, right? So probably you followed the use of exist in the previous example, and you'd wonder, like, why would we be worried about not exist, right? Exist makes a lot of sense. But what is the role of not exist? So, you know, I asked you a question related with what we had, and you people were spot on. You said, you know what, we will use not exist. Now let me ask you people to look at it and tell me, what is this query doing? Which is a slightly difficult question, right? What is this query doing? Select supplier name, supplier address, supplier city from supplier table, right? So all these suppliers attribute we have in the supplier table. Then we are using not exist, okay, and then there you know, we have a in between these parentheses, the outer parenthesis, we have a query, right? And this query will result something. It will return in some tuples, right? Our only interest is that this not exist will, this guy will return in true when? Can anyone guess when will this result in true? When this whole thing, correct, when this whole thing is empty. All right? Yeah, you are right. Fine. So we will be listing the supplier name, supplier address, and supplier city from supplier R only when the result of this whole thing that I have here marked using these lines is empty. Right? So might not be making any sense, like why are we interested in such a query? Good. Fine. Let's dive deeper and see what are we doing here. So what do we want? We want select star from product P where not exist. And here again we have one more query, and this place also, this place will be true when will we have this result as true? When this is also empty. Okay, so now question arises, why are we interested in this interesting not exist, not exist? Okay, fine, probably it will make sense very soon. Now let's try to decode this thing over here, where what we have, select star. Let's see how many tuples we are getting. Okay, select star from supplies S, where R dot supplier number, R is from here. Okay, it's an extremely interesting case of correlated query. See that, right? Where R dot supplier number is equal to S dot supplier number, and P dot product number is equal to S dot product number. Okay. So what is this query trying to implement? This query is trying to return the supplier name, supplier address, and supplier city for those suppliers where there does not exist a product that is not being supplied by the supplier. What does it mean? Okay, let's change this example for the timing, right? From this class, I'll come to you, right? Maybe you can answer, I'll ask you to answer this question, right? I just changed the example so that maybe other students can also answer. From this class, let's assume there are 50 students, just to make it interesting, okay? I want the name of the student for whom there does not exist a course in which the student did not get an A. What does that mean? The name of the student for whom there does not exist a course where a student did not get an A. What does that mean about that student? What's the GPA of that student? There does not exist a course in which the student did not get an A. Very good. He's got an A in all the courses. You see that? Right? A student who has got an A in all the courses can be written as the student for whom there does not exist any course in which he did not get an A. Right? Did not is kind of cancelling out. Right? Similar to the other question that I asked. So this not exist is kind of cancelling out. Right? And helping us in writing a query that in SQL we do have a clause like exist for existential quantifier, but we don't have anything for all directly implemented. So how do we implement that? We implement by using not exist, as you can see over there. Right? For these kind of queries, what we will do, we will reframe the query like the way we have done. Right? There does not exist any product which is not supplied by this supplier. Not exist, okay? Good. So what should we do now? Let's move on to slightly more interesting queries. Okay. So how are these queries interesting? Well, okay, the subquery was coming in the where. You want to have a look at those? Where is the subquery? After where? Where, right? After where we have a subquery. Here also the subquery is coming after the where clause, right? Look at the next query. Where is the subquery? Select p dot product number, p dot product name, and what? This result of subquery. Right? So what has happened? Where did we move to? Now we have moved to an example of a query where the subquery is in the select part of the select statement. Right? Along in one of the column that we have, like this column, which we are calling as this is our third column, total ordered. Right? This is our third column. What are the first two columns? The first two columns are product number, look at here, and product name, that's the second one. The third column that we have, total ordered, right? Look at it, it has been renamed as total order. And how did we get the value for this column? Well, for that we have this subquery written over here. Okay, here is the subquery. And what is the subquery doing? Subquery is kind of simpler only. We select sum of quantity from purchase order line table, which we are calling as POL, where P dot product number is same as POL dot product number. Okay. So what are we interested in? We are okay. Let's think about the usefulness of this query. Okay. So in this query, we want the information about the product number, the product name, and the quantity of that product which has been ordered, right? And where will we get the information about ordered? Well, that is there in PO line. All right, and yeah, we will join these two tables, and the interesting thing is that we have a from clause also, right? Why do we have from here? Because you know what, product number and product name we are getting from the product table. All right, so this query looks interesting, right? Was interesting for me also, because in the other courses that I taught on databases, never encountered this kind of a query, right? So it took me a little while to figure it out. And I don't know if you had seen something like this, right? And probably while you're preparing for the exam, you will understand. The more interesting would be if somebody is asking you to write a SQL statement that will do something similar to this one. Okay? something similar to this one means that the value for one of the column is coming from a query, subquery. All right, that will make it interesting. So here, one more time, just to summarize, the product number attribute that we have and the product name attribute that we have is coming from the product table P. Whereas this other attribute that we have, which is total ordered, is a derived attribute for which we are getting the value after joining the product table with the purchase order line table. Good, right? So we have seen two cases of subquery. The first case, which we have been kind of learning about, is where the subquery comes after the where clause. You just saw a subquery which is coming in the select part, right? Now, let's look at even interesting case where the subquery is sitting somewhere else, right? Just figure it out. Look at this query, right? And tell me, where exactly do we have a subquery? And how is it different from the previous two cases? In the previous two cases, the subquery occurred after where clause and in the select part, right? Where exactly do we have subquery now? From. Okay, so if someone is asking you, most probably I will ask, or maybe somebody in the interview may ask, in how many places of the select statement can we put a subquery, right? So before this lecture, you would say, okay, only after where. In the previous example, we have seen that the subquery can occur, let's see, select columns, right? From tables, where, right? So in the first case, we saw that subquery is coming here. Just now you saw that the subquery was coming here, and now in this example that we have, even the subquery can be put after the from also. All right, so let's see how will this work and what are we doing over here. So, okay, select m dot product number, m dot price number, m dot max price from what? M. What is this M? Well, that M has been defined in this box. Making sense? Select product number, m dot product number, m dot min price, m dot max price from M. And how is this M being defined? For that definition, we have written a subquery there. This is the SQ subquery. In that subquery, we want to select product number, the minimum of purchase price, and we'll call that min price, the maximum of purchase price that we'll call max price, from supplies group by product number. All right. Now, what do we have in supplies? Well, in supplies we do have product number, we have purchase price, right? So, what are we doing here? We are grouping by product number. So, once you group by product number, then for each product number you will have bunch of prices, right, which is being offered by different suppliers. Now, from that set of prices that we have for one product, we can compute minimum price and the maximum price. All right, good. And then we have one more interesting thing here, which is the where clause, which is probably simpler, but in this slightly complex looking query, we may miss the where clause, right? What is this where clause doing? Well, although for every product you will have the max price and the min price, right? Is it possible to have the same value for max price and min price? When will that happen? Sorry? Where there is only one entry, right? You got it. But it is also possible that maybe there are 4 suppliers, they are supplying that item at the same rate. It's possible to have, right? It can happen. But in our query here, we are only interested in listing those product numbers where the difference between the max price and min prices is greater than 1. Okay? Wait a second, sorry about that. I'll need to use the eraser here. Good. Right, so don't ignore this where clause. In the where clause, we want only those tuples where the price difference in the max price and min price is at least 1. And what do you have over here is the result. All right, so look at it. All the product numbers and the min price and max price, they correspond to the products where their prices is greater than 1. Good. All right, guys. You know, I found these things interesting. Let's move on, right, and learn few more queries. And I'll try my best to finish SQL in this class, so that from the next class we will try to learn something even more interesting. So, guys, let's do some very, very simple set operations just to revise our understanding of sets. You're looking at 2 sets here, set A and set B. Now we can think of very simple operation involving set, which is union of A and B, and in the union we will not have duplicates, and the union will have all these elements like 5, 10, 15, 20, 25, 30, 45 and 50. You know what is a union, right? I'll assume that that's the case. If not, then let me know. If we can think of the union, then we should also think of intersection. In the intersection of these 2 sets A and B, we'll have only those values which are common. All right, so these are going to be 10 and 30, right? So union, intersection. Do we have any other operation also left in sets? You can perform the union of the set, right? You can perform intersection of the set. What else can we perform on set? How is that subtraction defined? A minus B. Very good. Right? So what would be A minus B in this case? Whatever we have on A which is not present in B. Right? Let's see if we have that. A except B, right? That is A minus B. Right? So everything could be important, right? This could be a very, very simple thing, like what do we have for A minus B in SQL? So you have except A except B. So A except B will have everything in A which is not present in B. So like this 5, 25 and 45, these are the 3 values that we have only in A, not in B, right? And for that, either you say A minus B, or you better use the term except B. Okay, A except B. Now question arises, why are we going over these things? The reason is that we want to see if we have some support in SQL which will help us out in combining the results from 2 different queries. Okay, so what we will do, let's start with the union. All right, so well, let's see what are these queries. Okay, so there are 2 queries involved, right? Let me put these queries in 2 boxes. Wait a second. Okay, let me see if I can use my eraser here just to erase this line. That's fine, I'm good with that. Query A, query B and query C is the result of everything. Alright, so what is query A doing? We want what? Supplier number and supplier name from supplier table where the supplier city is New York. Right? We have special love for the suppliers from New York City. So, let's not impose any restriction on those. If they are from New York City, we want their supplier number and supplier name. That's one result. And how about the second query B? In the second query, we are interested in again supplier number, supplier name, but this will be slightly tricky. We want it from these 2 tables, supplier table and supplies, and we are interested in the supplier number and supplier name only for those suppliers supplying what? Product number 0915. All right. So we have two conditions, right? So what are we interested in? We want the supplier number and supplier name for the suppliers who are either in New York City or are supplying what? The product number 0195. If your query is that simple, then what you should do? First write these two queries and then do what? Union. Making sense? Right? First query is extremely simple. Supplier number, supplier name for the suppliers who are in New York City. All that information is in your supplier table. Just get that. And then for the second part, for those suppliers who are supplying the product 0915, for that we need two tables. Supplier table and supplies table. Right? Yeah, that's the reason we are doing a join here. R dot supplier number, R dot supplier name from supplier R, suppliers S, where R dot supplier number is equal to S dot supplier number and S dot product number is equal to 0915. And then let's do union. Right? That's what we learned. And this result is to be ordered by a supplier name ascending order. Good? Now, there's something which is very important when we are doing union. At least you can see over here. Okay? So, let me, okay, can anyone think about it like when can I do the union of the result of two queries and when can I not do that? Here I can do it, right? Because this is working. You can see this is working. Can you think about it? Why is it working and when will this not work? Union compatible, you know what it is, but this is called union compatible, right? Both of the attributes, look at it, supplier number, supplier name. You all got it, right? So this property is called union compatible. Right? And one good news is that union is supported, just like exist. Right? For this existential, we have the keyword exist. Similarly, for union operation, we do have the keyword union provided in most of the SQL vendors, like MS Access that I use in the next class. In ISE503 I know that union is available there. Good. Now, intersect should be straightforward, right? Once you understand how union works, similarly, we can think of intersection also. So, let's think about the intersection case with the same example. If we are interested in supplier number, supplier name for suppliers who are in New York City, that result, intersection of that result with the other result, the result of the second query. The condition is same. In the previous query, we were interested in union, right? There was an OR, but here that is an intersect. And the bad news is intersect is not supported. Do we really need an intersect? Is my question clear? Union is supported, but intersect is not supported. How can you rewrite this query to have the same impact as the intersect? Am I reaching to you people? Is my question clear? All right? There should be a reason why this intersect was not implemented by these smart people who are developing SQL, right? What do we need? Oh, let's understand our intention. Our intention is in listing the supplier name and supplier number who are supplying the product 0195 and they are also in New York City. Add an AND condition, right? Is it not that simple? Have one more condition and supplier city is equal to New York City, done. One more condition and you are done, right? So it's that simple, but anyway, you need to understand these things. So let's look at one more example here. This is except, right? Now I'll leave it on you. Let me ask you, what is this query doing? Because here, if you say just think about these two sets, right? This just think about these two queries. Select supplier number from suppliers, it will give us all the suppliers. Whereas when you are selecting supplier number from supplies, it will list those suppliers who are supplying the product, right? So this set minus this means these are the suppliers who are not supplying any product. Good. So if these questions are asked in exam, then these should be straightforward. Okay. All right. So now let's do some simple stuff here. We have done, the most of the stuff, but we did not talk about how to put the value in the table. So for that, we have insert statements. Now let's look at it. If you have a table called product, and you want to put some values in there, then you will be using this statement insert into. Insert into what? Insert into means we want to put the values in or the tuples in the table called product, and then this should be followed by the values that you have, right? So these keywords you should practice. Insert into the table product values followed by these values that you have, right? And how many values do we have here? 1, this is a string 2, 3 and 4. Okay, so in that order. So here we are not specifying the columns, that's okay, as long as you are providing the matching values, we are fine here. This is now the other possibility is which is I believe recommended, so that the chances of your bugs are reduced. In the second version, I'll call this version 1, version 2. In the second version, you are saying insert into product, you are also specifying the column names, right? Like product number, then it is followed by product name, product type and available quantity. This all goes inside the parenthesis, and then that will be followed by these values, right? Similar to the previous one, but here what we did provide the column name also, names also. Now here again 1, 2, 3, 1, 2 and 3. So guys, sometimes we do not provide all the values, right? So if you see in the product we have what, 1, 2, 3, 4 columns, but in the last query that we have, which I should mark as 3, the values that we are providing is only for product number, product name and product type, right? So this is the product number, that's the product name, and then the type. We are not providing the value for the quantity. So that is possible, we can do that. So what should be the result? It all depends on how the table has been defined, right? In the table definition, if you specified some default value for available quantity, say you said okay, default value 0, then it will have zeros when we don't provide a value. But if you did not specify any default value, then what should happen? Null. All right. So in that case, it will put the value null, value not available. Now it is also possible to do bulk insert. Bulk insert means bulk insert. In bulk insertion, we want to insert multiple values in one insert statement. So here let's look at an example of bulk insert. We want to insert the data in the product table that has these columns: product number, product name, product type, available quantity, values. Now you have these tuples inside the parenthesis. That's the first tuple. Then you have the second tuple and then the third tuple, right? So you can put the tuples next to each other, which will make your life a lot easier. Okay. And if we are moving along, then we can also insert the value into the table from a subquery, right? So probably this is very interesting. All right, so let's look into it. We have a table called inactive supplier. Let's assume that we have created one, and in this table we have only one attribute, supplier number. So we are inserting the values into the table called supplier number in the attribute which is sub number. And how are we getting those values? Well, just look at it. Select supplier number from supplier except select supplier number from supplies. Good, right? So what did this query do? Well, we just learned about this query, right? Which I have in that box kind of thing, or circle you may call it, which will provide us the supplier number of the suppliers who have not supplied anything, right? We can call them inactive suppliers. Okay, so that table can be easily returned, and what we can do, those results that we are finding out, we can use that as the tuples for bulk insertion. Great. Now, since we have learned about insertion, we should also find out about or learn about an operation which will do the reverse of insertion, right? So that's the delete. All right. So using the delete, you can remove the tuples. So let's look at this simple one. We want to delete the tuple for product number 1000. How to do that? You will simply say delete from product where product number is 1000. All right. So similar, I won't say similar to the select statement, but yes, some things we are getting from there, right? Like making use of a where clause. And in fact, we made use of a where clause in the previous one also, where we were doing bulk insertion. Let's look at one more query involving delete. So what do we want here? From the supplier table, let's delete all those suppliers where the supplier status is null. Okay, simple statements, delete from supplier where sub status is null. Good. Now you need to be very, very careful about this. We don't use the symbol, right? Whenever we are dealing with the comparison involving null, either use is null or not null. There was one question in the quiz too, I remember, that was checking your understanding of this concept. All right, so how about the third one? Let's see. This query is interesting. Delete from supplies which tuples where product number, right? From suppliers we want to remove some tuples. The tuples which will be removed, they should have the product number. What are the candidate product numbers to be removed, which we will find in this inner subqueries, right? Some of you were suggesting me the use of in. Let's see how will that work out here. So for that, let's first understand what do we have inside the subquery. Inside the subquery, we want the product number from product where product name has this string shard. All right. So what do we want? From supplies table, we want to remove those products where their name has that substring shard. Okay. So let's see what we have over here. Delete from supplier where not exist. Okay. What is this query doing? Right. We are deleting subtuples, some tuples from the supplier table, right? Which tuples we are deleting? That's correct actually, right? We want to remove those supplier tuples from very good, which are kind of inactive, right? We want to get rid of those. Great. But guys, again, this part is simpler, right? When it's like this, a program is given to you in an interview, right? Let's think about it. And the interviewer is asking you, okay, explain this program, what this program is doing, versus giving you a problem in the interview and asking you to write the program, right? Well, this is very important, understanding what this query is doing, but also thinking about the query, right? If I ask you this query, this question in the exam, like write a SQL query that will remove all the tuples from the supplier table corresponding to the suppliers who have not supplied any product. right? So yeah, you should be able to write some things. I mean, this is one possibility. You might implement it in another way, but this seems to be very straightforward to me. How about the next query, right? Yeah, pricey suppliers, right? And how do we determine whether they are pricey or not? Very good, right? By checking whether their purchase price is twice the average. But that's our criteria. Delete from supply S1 where S1 dot purchase price is greater than what? That value we can obtain from the subquery. All right, select twice the average of S2 dot purchase price from supplies S2 where S1 dot product number is equal to S2 dot product number. All right, and these things you will have to decode, right? Like which table you have to join, how should you join so that you could get the required information. And what is the last query doing here? Query number 3. Delete from product. No condition specified. It will do what? Delete all. I mean, all the tuples will be removed. And now, well, having looked at this insert and delete, now let's go and look at one more statement, which is update. So the update statement is used to update the value of some tuples, changing the values of some tuples, some attributes. So let's look at this one. I'll mark that as query 1. We want to update the table product, and in that table, how are we updating? We want to set the value of this attribute available quantity to 26, and that should be done for product number 0185. Good, right? Straightforward. Let's look at one more example of, I think few more examples, not just one more. Update statement. We will update supplier, set supplier status to default. What does this default mean? Who will give us the default value? Default should have been defined for this column, okay? So when we were creating this table supplier, then in that table creation, when we define this attribute supplier status, we should have mentioned that, this thing which is supplier status varchar 35 or whatever, and then default 10 some value, right? So here in this this update statement, we want the status to be set to default for all the records, which is whatever default value we have. How about the third statement here? Well, let me go over that. It's not too complex. We want to update the table supplies, where we want to set the delivery period to be delivery period plus 7, right? But this we are doing only for the supplier number that corresponds to daily wines, right? Seems like something has gone wrong with the supplier daily wines, right? Probably the daily wine supplier has some backup. I failed to find the correct word. It's a little busy, right? Or something happened with the supply chain of daily wines, and because of which we are experiencing some delay. Therefore, the delivery period that we had in supplies table for the supplier daily wines, we want that to be updated by 7 days. All right. So yeah, update supplies, set delivery period is equal to delivery period plus 7 for the supplier number. With supplier number, select supplier number from supplies where supplier name is daily wines. Okay. Why do we write this query in this way? Because probably the supplier that we have with the name daily wines is supplying multiple products, right? If that's the case, then for each product which has been supplied by the supplier named daily wines, we want the delivery period to be updated to plus 7. There's a delay of 7 days by the supplier daily wines. Good. Let's look at one more example of update. What are we doing here? Well, this is probably the toughest of the updates that we have seen. We want to update what? Supplies S1, and here how do we want to update that? Well, we want to set the purchase price and delivery price for supply S1, and that is being set by the values that we are getting from this subquery. All right. So, what is the subquery doing? Select minimum of purchase price, minimum of delivery period from supplies S2, where S1 dot product number is equal to S2 dot product number and the supplier number is 68. So, what is this whole query doing? Well, in this table which is supplies, we want to update that for the supplier number 68 with what? We want to set its purchase price and the delivery period, the minimum of the purchase price and delivery period that we have available for the products which are being supplied by supplier 68. All right, so let's move on, and the next update that we have is based on a table, right? So let's assume that we had to alter the table supplier, and in the supplier table that we have, we want to add one more column which is supplier category, right? So we are modifying the table by using the statement alter or alter table supplier. We want to add one more column which is called subcategory. It is of varchar type, and look at it, right? So something like this I was mentioning earlier in one of the query. Here for this column we are specifying default value, right? So what will happen after this statement? A new column will be created for supplier table, and that will be populated with the default value which is silver, right? So to all the suppliers that we have in our table, we are by default giving them the status of silver. Good. Now once we have given the status silver to all the records that we have in the supplier, we want to fix that. So how do we fix that? Here we go, right? Update supplier, set supplier category. This is a very interesting query. Set supplier query is equal to case. So this is an interesting part of the query where we are doing something very similar to if else statement, right? If you have done some programming in Java or Python, you would understand what I am saying. If and else statement. So now if and else statement in SQL are written with the help of case, right? So we will set the subcategory to case when supplier status is greater than or equal to 70 and is less than or equal to 90, then that supplier will have the status as gold. Otherwise, if the supplier status is greater than or equal to 90, then we will mark that as platinum, otherwise it is silver. Okay, and yeah, that's that, right? I love this one because I ended up learning about the case when, right? So case when else, it's very similar to if and else statement that we would write. And here is the example, is the table how it will look like, right? So when the status is 20, you are silver. When it is 90, you are gold. If it is greater than 95, you are platinum. And when this is an interesting case where the status was null, but since the default has been given as silver, so even if your status is null, we are making you silver. Good. Now questions? All right guys, today's lecture might be content wise very heavy. Content means probably we are learning a lot of statements, right? In the previous meetings we were focusing on just one statement, which was select statement. Okay, so now let's move on to one more very important part of the SQL statements, which are SQL views. Extremely important. Okay, so what is an SQL view? If you remember, right, we studied about three schema architecture: internal, conceptual, logical, and the external. Okay, and then we also learned about the physical data independence, logical data independence, right? And I think I asked that in your first quiz also. So guys, in SQL, whatever we did, like the data definition thing, that was defining the logical model or conceptual model. Now SQL provides this concept of views, which will help us in defining what is called external data model, right? So with the help of this, the views, which are the database objects in SQL, we can define the external data model. So now, how are the views defined? Now a view is defined by means of a SQL query. We will see that very soon, and its contents are generated whenever we are using that view in the application or within a query. So that I'll explain to you with the help of an example. Now the most important thing that you need to know about a view is that view is sometimes called virtual table, right? So well, the question is, why are they considered as a table? Because they behave just like a table. All right, once you have defined a view, then you can query on that view. All right, so that is the reason views are called virtual table. They are called virtual because the data in a view is not physically stored, as is the case with a table. So the data that you have in the table, they are actually physically stored, whereas the data that we have in the view, that is generated dynamically, right? It's not stored anywhere. That's the reason views are also called virtual tables, because they don't have physical tuples. Now what is the advantage of view? There are multiples. So as I said, you know what, it allows us for logical data independence, right? Why logical data independence? Because once the views are defined, you can keep the views fixed, and your application that you have may interact just with the view, not the physical table, right? So with the help of the view, you can implement logical data independence, which makes which kind of helps us in implementation of layer database architecture by defining the external view. Now this is what I wanted to show, right? Now with this, it will make a lot of sense, right? How to create a view. All right, so we will use the create statement. We were using create statement earlier to create domain, to create a table. We can also use create to create constraints, but here we will use the create statement to create a view, right? So well, in place of table, we are going to use the keyword view, right? So create a view, let's give it a name. Now the most interesting thing is over here, this part, right? So if I ask you to focus on this part, then probably that's not going to be difficult, right? What do we have here? Let's forget about view and all. So if you focus on this simple query, that is selecting what supplier number, supplier name from supplier, where supplier status is greater than 50. Very simple query. Okay, so when you're firing this query, then it will return the supplier number, supplier name, where the supplier status is greater than 50. Now this result that we are obtaining, the table that we are obtaining, we can give it a name, right? Or we can define it as a view. And how do we do that? We'll say create view, give this query the result a name, which we are calling as top suppliers, and what do we have in top suppliers? The result which has been obtained by this select query, right? So if you know how to write select query for a specific application, you can give it a name of a view, right? So that's how we define a view. Create view, give the name of the view, then use the keyword as, and after as you will have the select statement that will define your view. Good. Now, let us look at one more view, the second one. And how is the second one defined? Well, here we are creating another view, create view, give it a different name, top supplier SF, and SF is for San Francisco, where what is this, how is this view defined? As select star from top suppliers. What is top suppliers? Top suppliers is the view that you created in the first query, right? So, select star from top suppliers where supplier city is San Francisco. Now, something interesting you should notice in the second query. In the second query, we are selecting all the columns from top suppliers, right? So, what is top supplier? Top supplier is a view that you created in the previous query. Now, what you should have noticed here is that once we define a view, then that view can be used as a normal table. That is what we are doing over here. Okay? Yeah.